Hi, this is our interim presentation.
As you can see here, the product we choose is a non-industrial robotic clutch powered by two motors to realize gripper's motion, such as open, grip, and close. It is usually connected to a robotic arm, and its target consumer can be divided into two groups. The first one is consumers who enjoy playing with robotic toys. They can apply this product for their personal use or their projects. Another mainly application would be the education. So the professor or the educators could apply this robotics couch to illustrate the mechanism for the teaching purpose.
For our functional analysis fast diagram, we decided our primary tasks to be transport objects. Under this, the secondary task would be pick object, change position, and place object. The subtasks for place object would be to grab the object initially and then raise the object up so the position can be changed later on. In change position, we need to maintain some sort of force on the object and be able to rotate the object with the gripper to change the position. For our place object, the subtasks would be to lower the object back onto the surface, and release the object so it could be on the surface that we want it to be on. We also decided there should be some dependability, which is decided by having a stable movement in our gripper. And to enhance our product, we decided that there should be interchangeable attachments for our manufacturers to decide or help them pick a larger variety of objects. For our functional component mapping, we decided that the top plate, middle frame, side plate connector, main frame, and bottom plate all would serve the function of stabilizing the movement, as they would provide rigidity towards the entire gripper, whereas the servo motor, servo arm, and coupler link all play functions in maintaining force and rotating the object and or releasing the object, while the side plate allows us to raise the object using the holes at the bottom of the side plates that could be attached to a larger arm.
This is our assembly sequence analysis. We have two feasible assembly sequences showing here. The first one starts with top plate and the second one starts with the main frame. We have another chart to evaluate which one is the better one. We have 5 criterions for our evaluation. The first sequence got 9 points, while the second one got 13 points. In the first sequence, we assembly the claws at the very beginning, so it would create difficulty in transferring and handling, and also to test sub-assemblies. And another major problem is that there would also be difficulties in fastening the servo motor in the back to the housing in the middle.
Here's our BOM, and we assume the production rate as 50,000 units per year. Manufacturing costs were estimated under the help of custompartnet.com, assuming a 20% profit margin. The assembly cost is based on the manual assembly, where the time estimation is gathered from the chart provided in the lecture. We also approximate the labor cost as $20 per hour in the US. The part was manufactured based on 4 manufacturing process, which is machining, sheet metal processing, injection molding, and die casting. We also decided to purchase all the fasteners, connector, and motors to avoid the additional cost. So in the sum, the total cost of a mechanical gripper is $31.
In order to proceed with the product family design, first we need to identify functional differentiation. From the fast diagram, we identified grab objects, raise object, maintain force, rotate object, lower object, release object, and stabilize movement as common functions for both customer groups. On the other hand, interchangeable attachment is for the secondary group because educational institutes can modify the gripper shape depending on their needs. Primary customers, average individual purchaser, don't necessarily require interchangeable attachment because they are using the product for entertainment purposes. The platform components are used to fulfill common functions, while the module gripper is responsible for the differentiating function. On the left, we have the original product design with a default gripper shape. On the right, we have the varied gripper shape for secondary customers. From the assembly sequence analysis, sequence 2 was a better choice for our requirements. In this product family design, the sequence 2 is represented in an assembly sequence diagram, which is labeled as original assembly sequence. However, the diagram was modified to realize delay differentiation. At first, right claw was fully assembled in the left, and finally couplet link. By modifying, the right and left claws are assembled without the grippers, and the coupler link, and finally the grippers are attached at the end. That is all for our interim presentation. Thank you.